Morning, Algebra 2 students. Hope you're all doing well. Hope you had a good, relaxing weekend. So today we're going to be looking at reviewing things that we've looked at before. Next or later on in the week, we're going to have a matching part, and I'm going to show you, or I'll talk to you more about that when that comes and how we'll do that. It'll be some sort of different format or platform to go to. But right now, let's look at this do now. So we have x cubed plus 5x squared minus 4x equals 20. And we have p to the fifth plus 5p to the third minus 36p equals 0. So what methods are we thinking of using to solve these? That's right. First thing we need to do is we need to figure out what is our number of terms. So the number of terms, we count 1, 2, 3, 4. So we have 4 terms. And by now we should all be thinking, oh, 4 terms, I need to do left side, right side. And how many terms do we have over here? We have 1, 2, 3. Remember, we don't count 0 as a term. So we have 3 terms over here. And what are we thinking for factoring there? That's right, we're thinking of RS method. Always remember we need to simple factor first if possible. This one over here we said left side, right side. But first, remember we always have to set it equal to 0 like the one on the right is. So we need to subtract that 20 over first. Make sure that our exponents are all in the same order. So now we have our left side, our right side. So we have x squared, x plus 5. We have minus 4. Again, x plus 5 equals 0. We can factor out an x plus 5. Then we have x squared minus 4. So now we have something that's squared, and we're thinking, is 4 also a perfect square? And we're like, yep, that is. So then we have a difference of squares. So remember, we can rewrite this as x squared minus 2 squared, which is going to be the same as x minus 2 and x plus 2. And again, that's equal to 0. We still have x plus 5 equal to 0. So we can already see what their solutions are for this left one. We have x equals a negative 5, opposite sign of the factors. We have x is going to be, we can do the next one, a negative 2, and then also positive 2. All right, so now we can do the right side one as well. So we have 3 terms. You said RS method. So we're thinking what 2 numbers multiply together to equal negative 36, add up to 5. So we're thinking R times S equals negative 36 times 1. And then also R plus S equals the middle term, positive 5. And by now we should say, oh, it's going to be positive 9 and a negative 4. Those multiply together to equal this, add up to 5. So we're thinking a positive 9 and a negative 4. So we have p to the fifth. Uh-oh, I'm just realizing that looks like we forgot to simple factor first. So notice that I posited like p to the fifth, and then I'm like, wait a minute, I got a lot of extra p's here. So I can actually divide out a p first. Notice that doesn't change my R and S, but if I take out a p first, or a variable first, then I have p to the fourth plus 5p squared minus 36, no p, equals 0. So I already know that one of my solutions is going to be, that's right, p equals 0. Because I can already set that p equal to 0. So we can kind of like, we can figure that we've already done that. Now we just need to figure out what are these other 4 zeros. Remember, we're looking for 5 possible solutions. We had 3 solutions with x to the third. We're looking for 5 solutions with p to the fifth. So let's stretch that middle term like we were trying to. So we have p to the fourth. That part doesn't change. Now we're going to have plus 9. And that's right, we have to use p squared. And then minus 4p squared. And then minus 36. So 4 terms, left side, right side. Same as what we just did. So we have p squared plus 9. Now we'll take out a -4. Whoops, I forgot to put a p squared here. I said it, but I didn't write it. Take out a -4. Can't take out any p's. So we have p squared plus 9 again. Notice how these processes should give us the same things each time. All right, now we have p squared minus 4, p squared plus 9 equals 0. Notice variable squared minus 4, it's the same thing we had up here. How did we solve that? Well, we had a -2 and a 2 coming from that, because we're going to have p squared minus 2 squared, p minus 2, p plus 2. So p minus 2, p plus 2, because we just did that over here. All right, and then we have p squared plus 9 equals 0. And then now we're thinking, how are we going to solve these now? So we already know that we're going to have a +2 and a -2, opposite signs here when we solve it. So p equals, we have a +2 and a -2. We can rewrite these later. Now we have p squared plus 9 equals 0. Let's see what we get here. So p squared, oh, and why doesn't this one factor? That's right, this is a plus, not a minus, so it has to be a difference of 2 squares. 9 is the same as 3 squared, p squared is a perfect square. That's got to be a minus in there. So this p squared equals -9, and we see, oh, it doesn't factor because we're going to get something imaginary here. So we have p equals plus or minus the square root of -9, which is going to be the same as plus or minus square root of 9, square root of -1, plus or minus 3, and square root of -1 is I. So we also have p equals plus or minus 3i. So we have all 5 up there. Remember, this plus or minus is 2, so that gives us 4, and then an extra 1 for 5. So we can write this as the set -2, 0, 2, and we'll just put those imaginary parts together. Oops, I didn't make the squiggly line bracket. Oh. Looks like it's not going to happen. Not enough space back there to do that. There we go. All right. So we have our 5 solutions, our 3 solutions. So let's look at today. So we're going to be doing some more practice for factoring. We're doing another volume problem. Notice that we have our standard quiz next Tuesday, Wednesday. Remember, that's this Tuesday, Wednesday would be a week from today. And we're going to solve volume problems using polynomial equations, because we first have to remember, write that polynomial equation, and then we're going to review solving some polynomials by factoring. And again, like I said, next class we're going to do some sort of matching activity using a different program. So find the real solutions of the following equation. When we're solving, our first step is to do what? That's right, step 1, we want to set equation equal to 0. So set equal to 0. So we have 25 x to the 4th minus 100 equals 0. First step. Now we're going to count our terms and decide what method. So count terms, and we're going to determine what method. Determine method. How many terms do we have? You've already been counting. We have 2. So 2 terms. 2 terms is going to tell us we have a special case. Possible. But can we do any simple factoring first? So can we simple factor? That's right, 25 and 100 are both divisible by 25. So we have x to the 4th. We have minus, what's 100 divided by 25? That's right, it's 4. So now we have 25 out here. Is that going to change? Is that, if we set 25 equal to 0, what does that give us? That's right, there's no x's here, so this 25 is basically just dividing both sides by 25. If we divide 0 by 25, that still becomes 0. If we divide 25 by 25, that becomes 1. So we're really left with x to the 4th minus 4. And do I need parentheses? That's right, I don't need parentheses. All right, so we determined our method. We're going to do special cases. So we have x to the fourth minus 4. And we should really, I'm going to put a 1.5 step in here. And something that we should have done first is simple factor. All right, so now do we have something squared equals something, or do we have something squared minus something squared? And this is a little hard to remember. When it's x to the fourth, we can still write it that way. So we really do have, and I'll move it over here, we really do have x squared is being squared minus 2 squared equals 0. So it's really going to be x squared minus 2 and x squared plus 2. And let's see what we get for solutions here. So we have x squared minus 2 equals 0. We have x squared plus 2 equals 0. We have x equals plus or minus the square root of 2, because we're going to add 2 and then do definition of square roots. On this other side, notice that that's going to be a minus 2, so it's going to be x squared equals plus or minus the square root of negative 2. So when we write out, oops, I didn't mean squared, we're going to have x equals. So what I'm doing here is I'm subtracting 2 and then doing definition of square roots. So x equals plus or minus the square root of negative 2. And then if I just simplify those over here, and then our last step after we do our factoring method, we're really just going to solve for x. So we have x equals, we have our set, we have plus or minus square root of 2. And then this is actually going to be plus or minus square root of 2 square root of negative 1, which tells us that that's going to be I. So plus or minus square root of 2 I. All right, so let's look down here in the next one. Notice we had 4 solutions, plus or minus, so that's 2. 2 gives us a total of 4. All right, let's look at this next one. And I made some problems here so that we have a few to look after. Again, we want to make sure that we simple factor first, set it equal to 0. We're solving here. So we're thinking x to the fourth. And then we have to subtract that 7x cubed over. So minus 7x cubed plus 12x squared. Remember, I want to put these in order. 4, 3, 2 equals 0. How many terms do we have? 1, 2, 3. That tells us we're going to do, that's right, we have 3 terms, which means we're going to do the RS method. What 2 numbers multiply together to equal 12? Add up to 7. Three and 4. Multiply together to equal 12. Add up to negative 7. Also negative 3, negative 4 multiply together to equal 12. Those add up to negative 7. So it looks like these will be our R and S. But did we simple factor first? We didn't again. So let's notice that that's something that's pretty easy to forget. So we should have really said x squared, because notice I'm factoring out the smallest number there. So it's really x squared minus 7x plus 12 equals 0. And this is quadratic now. So this is just going to be the same as what we've done in the past. So we already have x squared equals 0. Notice that that's a multiplicity there. So that's really just x equals 0, and it happens twice. So this one counts as 2. And then let's factor this part. So we already took care of that. So now we have x squared minus 3x minus 4x plus 12 equals 0. Factor left side, right side. X minus 3, oh, we're factoring out an x. A negative 4, x minus 3. So we have x minus 3, x minus 4. And when we set these equal to 0, opposite signs. So we know that it's going to be x equals a 3, x equals a 4. We have x equals 0. So if we put all these together, we have x equals 0, 3, 4. And remember that 0 happened twice. So we see 3 here, but it was really, this was twice. We know that that's going to be a max or min on the x-axis. All right, moving on to the next one. So let's look at number 3 here. All right, so again, our process is to, step 1, we want to, that's right, we want to count the number of terms that we have. So we have 1, 2, 3, 4 terms. What process are we thinking of using? That's right, we should all be saying left side, right side. All right, so let's first set it equal to 0. So we want to have x to the 5th. We'll subtract x cubed. We'll subtract 8x squared. Well, because it's already over there. Then we have to add 8 because we have to do the opposite. So we're going to add 8. And then that's equal to 0. So how many zeros are we looking for? That's right, 5 zeros. We're looking for 5 solutions. And another question, can we simple factor? Can we divide each of these terms by something? And I'm going to take off this part up here so we can see this a little clearer. So can we simple factor? You're right, we can't. We can't divide by x's because there's no x here. We can't even divide by any numbers because there's no, I mean, you could divide by a 1, but that doesn't do anything. All right, so we already said left side, right side. So let's look at our left side. What can we factor out? X cubed. All right, so I'm already thinking, ooh, x cubed. Maybe I'm going to have a something that has to do with cubes. All right, x to the 5th divided by x cubed, we get x squared minus 1. What are we going to divide by the right side? That's right, a negative 8. Because then if we divide by negative 8, we're going to get x squared minus 1. And we want to make sure that these two things are the same. So let's take out that x squared minus 1 and that x cubed minus 8. All right, so what do we have for terms now? That's right, we have 2 terms and 2 terms. So we're looking for special cases now. So 2 terms, we're looking for special cases. Do we have difference of cubes? Do we have sum of cubes? So remember we identified that cube earlier. So x cubed is 8 a perfect cube? That's right, it is. So we're really looking at x cubed minus 2 cubed. So we have to remember that if we have something cubed minus something cubed, what does it equal? All right, yep, a minus b, because it's going to be the same sign. And then what do we have? That's right, a squared plus, if it goes minus then it's plus ab plus b squared. So this is the difference of cubes. And then what about this other one? Does this simplify? I see a perfect square is 1 a perfect square. That's right, it is. So it's really going to be a squared minus b squared. And that, remember, is a minus b and a plus b. So it's really x squared minus 1 squared. Oops, almost forgot the 2 there. Equals 0. Let's just rewrite that just so we can minus 1 squared. All right. So let's rewrite this out. So I'm going to rewrite it out over here using these formulas up here. So now this is going to change to this. This will change to this. So we have, let's do the first one, the x squared part first. So we have x minus 1 and x plus 1. All right, now we have x minus 2. I'm following this pattern up here. If let me remember, x is going to be a and b is going to be 2, and we just take x and 2 and plug them in. The signs will be the same. It's not a negative 2, it's just a 2. We plug an x in for the a's and a 2 in for the b's. All right, so now we're going to have x squared 2 times x I'm sorry, x times 2 will be 2x. And then 2 squared is 4. All right, so we can see already 3 solutions here. Remember, this is all equal to 0. I should have put that in over here. All right. So now we have x is going to be, we can write that over on the other side here, x equals our set. We have so far -1, +1, +2. That's from this -1, opposite sign, +1, +2. And then how about this x squared plus 2x plus 4? So remember, that's quadratic. And whenever we do difference of cubes or sum of cubes, this part is going to be, it's going to give us some unreal zeros. So we have x squared plus 2x plus 4 equals 0. That's right, we need to use the quadratic formula. So x equals, all right, so x equals opposite of b plus or minus square root. For some reason, it seems like, no, the thickness is good. All right, so we have x equals -2 plus or minus square root. We have b squared, so 2 squared is 4, minus 4 times a times c, 1 and 4, all over 2 times a, so 2 times 1. That was 2 squared, that became 4, so that should have been 2 squared. All right, so 4 minus 16 gives me a -12. So I have -2 plus or minus square root of -12 over 2. Square root of -12 can simplify. And we're not going to be doing number 4 here. Oh. All right, so then we can, square root of 12 would be, so let's do some split the heart. Square root of 12 is going to be, square root of -12 would be square root of 12. Square root of -1 over 2. That'll become I. -2 over 2 becomes -1. Square root of 12, 4 and 3, 2 and 2. So we have 2 square root of 3, I, next to the fraction, over 2. Oh, looks like these 2's are going to simplify. So in our final answer, we have -1 plus or minus square root of 3 times I. Remember, the I is outside of the square root. So let's look at this here. So we have -1 plus or minus square root of 3 I. All right, and then this will be our set. 1, 2, 3, 4, 5 solutions. 5 was what we were expecting. All right, so we have some time for one more problem here. We're gonna look at this math application. So it says the dimensions of a box of animal crackers are shown. Each animal cracker takes up about 0.75 cubic inches. If the box is half full and has 80 animal crackers in it, determine the volume of the box. So what's our, again, let's think about this as 3 reads. So 3 reads tells us that the first one, we just look at, what are we talking about? We're talking about animal crackers. We're looking at a box. We're trying to figure out the volume. All right, so let's look through it again and let's underline some things. So dimensions of a box of animal crackers are shown. So that's this image here. So we can see that we're shown here. We're shown that it's x on the bottom, x minus 5, x minus 3. Got some animal crackers in there. But it says, okay, so animal cracker 1 takes up 0.75, half full, and you have 80 animal crackers in it. So think about, how can we figure out the volume? What's the volume equal? And it tells us here we have 0.75, we have the box is half full, 80 animal crackers in it. So it says determine the volume of the box first. So what's the volume? We do know that it's these things multiplied together, so we already know that. So we know that our volume is really equal to x times x minus 3 times x minus 5. And I'll just again show that this bottom was x, so x minus 5, x minus 3. So that's part of the volume, but what's the number for the volume in cubic inches? Well, we know it's going to be 0.75 because that's one cracker, but we have 80 crackers, so we need to multiply it times 80. But it says the box is half full, so that would only be if we had the animal crackers filled up to that much. So imagine all of this as animal crackers. So how are we going to figure out the rest of it? If it's half full, that means, oh, we're going to need to multiply it times 2 then. So because it's half full, we need to multiply by 2. So what do we have? So let's look at our calculator. So we have 0.75. We are multiplying that times 80 and then times 2. All right, so it says 120. So 120, and that's inches cubed. So that's our number, right? And we're going to take that volume, and then what do? That's right, we set it equal to our dimensions that we don't know. So and remember, I like to write this part first. So x minus 3, x minus 5 equals 120. So what do we have to do? That's right, multiply all this all out. So x times x squared, x times negative 3x. All right, what do we do next? Keep multiplying, you're right. X cubed, x squared times negative 5x squared. Negative 3x times x, negative 3x squared. Negative 3x times negative 5, positive 15x. And then let's bring this 120 over. Minus 120 equals 0. So we set it equal to 0. Can we combine any like terms? Looks like I made a mistake here. When I said negative 3x times x, I said negative 3x squared, but I didn't write it. And that would have been very problematic. All right, so now we have combined some like terms. We have some like terms here. Let's just double check this. So x squared times x was x cubed. X squared times negative 5x is negative 5x squared. So I multiplied that to both. Now I'm going to multiply negative 3x to x, negative 3x squared, negative 3x to negative 5 is positive 15. All right, so I'm just double checking because I know that sometimes I make mistakes here, just like I did. All right, so we have x cubed minus 8x squared. All right. And then we have plus 15x minus 120 equals 0. How many terms do we have? 1, 2, 3, 4. All right, so it looks like we're doing left side, right side. Take out an x squared, x minus 8. All right, so is 15 times 8 120? Let's try it. 8 times 5 is 40. 8 times 1 is 80. So 80 plus 40, that's 120. All right, so let's take out the 15. And it'll be x minus 8. We have x minus 8, x squared plus 15. Now notice that we can already see, oh yeah, that 8 is probably going to be our solution, because remember this, x squared plus 5 equal to 0. Oh, x squared equals negative 5. That's not good. That's going to be imaginary, right? Because then it would be, I'll just move it down. Because now we have x equals plus or minus the square root of negative 5, and we're like negative numbers, that's going to be imaginary, so we can cross that out. X minus 8 equals 0. So we're like, oh, that's got to be our solution. X equals 8. So that means 8, 3, and 5. So x equals 8. X minus 5. So that's going to be 3. Is 8 minus 5. And then this will be 8 minus 3. So that's 5. So it's really 8 inches by 3 inches by 5 inches. Remember, our problem said to find the dimensions of the box. Dimensions of the box means that we have to find this part. All right, so go measure your animal cracker box. Is it 8 inches by 3 inches by 5 inches? It is, great. Okay, so nice work. And then let's go on to correct our assignment here. So we have problem 1, 2, and 3 on the screen here. All right, and then we have problems 4, 5, and 6. Notice 6, I had to kind of write it out. That one got kind of messy. Because what you ended up having here was 125x cubed minus 27. And then we had to do a quadratic formula to get those imaginary solutions there. All right, and then your homework assignment for next time, 1, 2, and 3. Notice what they say. Factor the expression. Oh, factor the polynomial. Factor the polynomial completely. Make sure you have all those factors. And let's look at 4, 5, and 6. 4, find the solutions. How many solutions are we expecting? How many terms? Figure out the process. Find the solutions to the equation. Okay, so more solutions. How many are we going to have? All right, and then number 6. Ooh, jewelry box. Nice, exciting. The volume it gives us, find the dimensions. All right, so the dimensions, we're thinking something by something by something by something in inches, right? So some sort of inches by some sort of inches by some sort of inches. All right, and then let's look at our ticket out for today. Finish the equations by factoring. Ooh, so we have some things here. So what does this factor to? Maybe you may have to look back on the notes. It's actually in today's notes. This is right here. How about this one? What does this factor to? And then we got another one. Oh, did we do this one in the notes today, or was it this one? I can't remember which one. Actually, I remember, but you may not. All right, so we're at 30 minutes. Sorry for the long-winded conversation today. So again, so watch, do your corrections, then do the assignment, and turn it in. Be looking for Thursday's video, and again, you'll be looking at something else about what you're doing. Hope you all have a great day, and it's blue skies out today, so I hope you enjoy it outside as well. Talk to you later. Bye.